Right, you need loads of information to do this question. First of all, you're going to need implicit differentiation. Secondly, you're going to need to use the product rule. And thirdly, you need this bit of information. Lines that are parallel to the y-axis are vertical lines. And if lines are vertical, that means that their gradient is undefined. So what that means is that you divide by 0. So anything that's undefined that has an asymptote has been divided by 0. So that has implications for your gradient. Right, the first thing you're going to do is you're going to differentiate this. So you differentiate using the product rule. So you end up with x. You differentiate your sine y with respect to x. So you're going to get cos y dy dx. You then leave your sine y and you differentiate your x with respect to x. You're then going to differentiate your cos 2y with respect to x. So you end up with x cos y dy dx plus sine y minus 2 sine 2y dy dx equals 0. You're now going to make dy dx a subject, so you're going to factorise. So you get everything on one side that's got a dy dx in it, and I've chosen to do this because I think it's nicer and it keeps the sine y positive. You then take out your factor of dy dx. Sorry about my little bit of a scribble there. So that's what I've ended up with. Dy dx is sine y all over 2 sine 2y minus x cos y. Now, I need that to be undefined if the gradient of the tangent is going to be parallel to the y-axis, i.e. vertical. So I've written that down. Okay, for this to be undefined, the denominator must equal 0. So you simply put that denominator equal to 0, and that's what you get. Okay, so that's my first page of answers. This is a 3-page answer, don't be scared. Right, I know the identity sine 2y is 2 sine y cos y. So rewriting my denominator put equal to 0, I'm going to get 4 sine y cos y minus x cos y equals 0. I know I can't divide by cos y because cos y equals 0 is a solution. So I can't divide. I take out a factor. And when I take out a factor, that's what I'm left with. So I've got a situation where I've got cos y equals 0 or 4 sine y minus x equals 0, which means 4 sine y is x. I'm going to deal with this bit first, cos y equals 0. Now in the back of my head, I go back to the question and it tells me that y lies between 0 and 2 pi. That's good. But it also tells me x is greater than or equal to 0. I can't have a negative x. If I solve cos y equals 0, I end up with 2 solutions, pi by 2 and 3 pi by 2. But I'm well aware x can't be 0. So I go back over to this bit here, which I know, and if y is pi by 2, everything's fine. But if y is 3 pi by 2, x becomes 4 lots of the sine of that, which is negative 4. X can't be negative 4. The question tells you x is positive. So your only answer from cos y equals 0 is y equals pi by 2. I'm now going to put that back into the original equation from the question. Go right the way back. So that's what you get when you substitute that in. You rearrange it and you end up with x is 7 over 2. So at long last, you do have 1 point. 7 over 2, pi by 2. Right, go back to your 4 sine y minus x equals 0 or 4 sine y equals x. Now find what turning point or what points you're going to have with this. So put that back into the original equation. So if you do that, you replace your x with 4 sine y. So you're going to end up getting that when you put it back into your original equation. You know you've got 3 identities for cos 2y. You're going to use the one that has sine squared in it, because that's going to be your most convenient. Now go to the third page for this answer. It's a good question. So rearranging that, I end up with 4 sine squared y plus 1 minus 2 sine squared y equals 5 over 2. Sort that out. Divide by 2. Okay, now I'm going to square root, but I know that when I square root, I take the positive and negative root. Right, good old cast. None of those dodgy curves, way too hard. So, first of all, if sine y is root 3 over 2, you know you'll get those solutions. Now, they're all good because 4 times the sine of both of those is going to be positive. So, from those y values, putting it into your x condition here, you're going to get, if y is pi over 3, you know x will be 4 times the sine of it, 4 times root 3 over 2. So that's a point. You also know if y is 2 pi over 3, x again is 4 times the sine of y. So again, you're going to get the point 2 root 3 and 2 pi over 3. You did, however, have the solution sine y is minus root 3 over 2. You must show that you're going to discount this. Don't just leave it. So if sine y is minus root 3 over 2, you know that x is 4 times the sine of y. X will be minus 4 root 3 over 2, negative. We know x has to be positive, so there's no way this is going to happen. Obviously, be careful. No valid solutions. So here are your 3 points. Well done.